In this lesson, we are going to be looking at composing and decomposing functions. By definition, the composition of f and g is written as f composed of g. That little circle right there means composed of. And what that means is that we take the function g and we plug it into f. And the order of which these are written does matter because it's always the second function getting plugged into the first. So for example, if I had written g composed with f of x, this means to take the function f and plug f into g. So let's look at some examples. Example 1, we have two functions, f of x and g of x. The first thing we want to find is f composed of g of x. This means that everywhere that there is an x in the function f of x, I'm going to take that x and replace it with the function g. So instead of x squared minus 3 times x plus 1, so I have went ahead and wrote a blank set of parentheses for everywhere that there was an x in the first function f. And now we're going to take the second function g and we're going to be plugging that into all of those parentheses. Now I'll go ahead and start simplifying this. We do need to make sure that we FOIL out that 5x plus 4, and I'll go ahead and distribute that negative 3. When we FOIL out the 5x plus 4, we'll get 25x squared plus 40x plus 16. We still have that minus 15x, and the negative 12 and the positive 1 will make a negative 11. And the last thing I'll do is just finish combining like terms. So this is our answer for f composed of g of x, where g was plugged into f. Again, the order that these are written in does matter. The next part of this problem wants us to find g composed of f of x, which means now I'll be taking the function f and plugging it in for all of the x's that are in the function g. So when we look at the function g, we see 5 times x plus 4. So I'll just set up 5 times something plus 4. And that something I want to replace with what the function f is, which is x squared minus 3x plus 1. Then we'll get started simplifying this. I'll just distribute the 5 to give me 5x squared minus 15x plus 5 plus 4. And the last thing I will do is combine like terms. And with f composed of g of x, we are going to be taking the function g and plugging it into the function f. So everywhere that there's an x in the function f, so instead of 5x squared minus 1, I have put a blank set of parentheses. And inside of that blank set of parentheses, I am going to plug g into f. G is the square root of 5x plus 5, so I have put that in that set of parentheses. The square root that's in that function is going to cancel out with that squared. So that's just going to leave us with 5 times 5x plus 5. No more square root, and then we still have that minus 1. I'll go ahead and distribute that 5, which leaves us with our final answer after we combine like terms of 25x plus 24. Moving on to g composed of f of x. This time we're going to be taking the function f and plugging it into the function g. So g was the square root of 5 times x plus 5, but I'm just going to put a blank set of parentheses for where that x is, and then inside that blank set of parentheses we're going to be plugging in what the function f was. I'm going to plug f into g. It's always the second function getting plugged into the first one. So here I'm putting 5x squared minus 1. We'll go under, notice that here everything is under the square root. We're going to distribute the 5 under that square root to give us 25x squared minus 5 plus 5. The 5's will cancel out and we're left with the square root of 25x squared. We can separate this into two separate square roots, and the square root of 25 is 5, and the square root of x squared is the absolute value of x. In example 3, these these examples are a little bit different because now we actually have numbers on the inside of our functions that we want to evaluate them at, not just variables. So there's two different ways that we could do this. We could go in and find the original composition function like we have been doing, and then we could go in and plug x is equal to 9. So we can find f composed of g of x and then plug 9 into that. So I'll start off by finding f composed with g of x. I'm taking the function g and I'm plugging it inside of f. So everywhere that there's an x in the function f, I'm not going to put anything down there. So right now I just have something minus 4. Where the x was, I didn't fill that in. And in there, I'm going to be plugging in g, which is 2x minus 8. So simplifying this gives me that f composed of g of x is 3 divided by 2x minus 12. So now that we have that, we can now go on to find f composed with g of 9, because now we can plug 9 into this function. So this leaves us with 3 over 18 minus 12, which is 3 over 6, which leaves us with 1/2 for our answer. Another way that we could evaluate f composed of g of 9 is we could first evaluate g of 9 and then plug that into f. So I could start off by finding g of 9, which means I just need to plug 9 into g, which gives me 2 times 9 minus 8, which is 10. And then I could take that answer of 10 and plug that into f. And then f of 10, we're left with 3 divided by 10 minus 4, which is 3 over 6, which is 1/2. I'd like for you all to try this second example in number 3. We will go over it together in class, and I'd like for you to try to work this out both ways. So first, I'd like for you to try to solve this by first finding g composed with f of x, and then once you have that, then plug in x is equal to 6. Which would give you g composed of f of 6. And alternatively, I would also like you to try to evaluate this by first finding f of 6, and then once you have that answer for f of 6, plug that into g. So number 4, they ask us to find f composed with g of x and the domain of that function. Let's first start off by just finding f composed of g of x. We know that this means we need to take the function g of x and plug them into f, which is going to leave us with 3 over this x right here in f. I'm going to replace that x with what the function g is. So there's the function g, and we already had that plus 2 right there that was in the function f. We can simplify this to be left with 3 over 3x, because the negative 2 and the positive 2 will cancel, and then the 3's will cancel, and we're left with 1 over x. Now lastly, let's talk about the domain for this function. Now looking at this function here, has a denominator of x, so we definitely want to make sure that x does not equal 0, because if x is equal to 0, then we would have a domain issue. And so the domain of this function is all of real numbers except for 0. In number 5, we're asked to find two functions, f of x and g of x, such that if I were to compose them, we would get this function h. So we need to think of a small function and a big function, where if the smaller function, which in this case would be g, were plugged into the bigger function f, we would get the square root of 3x minus 7. So to achieve that, I'm simply going to plug 3x minus 7 into the square root of x. So now you can see that if I combined those two functions and I took g and I plugged it into f, we get exactly the function that we're looking for. I'd like for you all to try example 6, which is doing the same thing we did in example 5, coming up with two functions f and g, so that when you compose them, you get the function h of x. Keep in mind that there are directions here that state to use the identity function, so neither one of your functions should be x. In the last example, we're going to use this graph to evaluate these expressions here. Keep in mind that g composed of f of 1 is the same thing as g of f of 1. So we need to take 1 and plug 1 into f. This function right here is f, so we can see that when we plug 1 into f, we get out 2 because the point 1, 2 is on that graph, and so f of 1 is equal to 2. So we're left evaluating g of 2. G is this graph here. And at 2, I can see that the point 2, 4 is on the graph of g. So g of 2 is equal to 4. I would like for you all to try example 7b, and we will go over that together in class.